What if I told you that by 2026, the algorithm that determines whether your resume even gets seen or whether your business post gets any traction at all is going to be actively hunting for your typos? And not to penalize you, but to actually reward you.
I mean, it sounds completely counterintuitive to, everything we've ever been taught about professional communication.
It really does. Because you spend your whole life learning to polish your writing, right?
Yeah.
You run it through spell check, you try to make it sound perfectly professional, and now the underlying mechanics of the internet are shifting so radically that perfect grammar might actually get you shadow banned.
Yeah, it's wild.
So, welcome to this custom deep dive. Today
Yeah.
we are giving you, yes, you listening to this right now, X-ray vision for the modern internet. We are going to teach you how to look at a wall of text or a corporate image or just your own social media feed and instantly see the underlying digital bones.
And honestly, it has become a mandatory survival skill at this point, because the line between what is a genuine human thought and what is just a statistical probability generated by a machine, well, it has effectively evaporated for the casual observer, but the markers are absolutely there if you know how to look for them.
Right. And to give you that superpower today, we have an incredible stack of source documents to pull apart. We are starting with this insider field guide from Wikipedia's editing community. It is literally a manual on how they spot undisclosed AI-generated writing.
Which is fascinating on its own.
It is. And we are also looking at leaked 2026 algorithm strategies for platforms like LinkedIn and putting those side by side with these really advanced multi-layered prompting frameworks straight from Google. And finally, we have this rather intense manifesto on why massive enterprise AI systems are just failing catastrophically in real-world production.
It's definitely a varied stack of documents, but they all really circle one central defining conflict of the current internet.
And that is the mission for our deep dive today. We are exploring the tension between what artificial intelligence wants to do by default, which is basically produce confident, blurry, generic sludge, and what it can achieve when it is engineered with absolute, unforgiving precision.
Exactly. We are looking at the difference between, letting a tool just run wild and actively building mathematical cages to force it to be useful.
Okay, let's unpack this. Let's start with the wild side. Let's look at what an AI model sounds like when you just let it off the leash and ask it to write something. So the Wikipedia field guide calls this the AI's idiolect.
Right. So an idiolect is simply an individual's distinctive, unique way of speaking or writing. Like, you have an idiolect based on where you grew up, the books you've read, the slang of your friend group.
Right, it's personal.
Exactly. And large language models like ChatGPT or Gemini, they've developed their own highly identifiable idiolect. But it obviously doesn't come from a childhood or a hometown. It comes from a foundational mathematical reality of how they are built, which is this concept called regression to the mean.
Regression to the mean. Okay, let's break that down. A mean is an average, right? So the AI is constantly trying to regress or pull back toward the absolute average of human language.
That is the core of it, yeah. Because large language models are, at their heart, statistical prediction engines. They have been trained on terabytes of data, which is essentially the entire public internet.
Just a massive amount of text.
Right. So when they generate a sentence, they are calculating the most statistically likely next word or sequence of words that would apply to the widest possible variety of scenarios they want to be broadly applicable, which mathematically means they really want to avoid outliers.
So they are terrified of being weird.
Basically, yes. They are heavily penalized by their training for being wrong, and the absolute safest way to never be wrong is to just be generic. If you map human language on a bell curve, the AI aggressively avoids the edges. It just wants to sit right in the fat, comfortable center of that curve.
That makes total sense. And the Wikipedia guide has this phenomenal example of what happens when that statistical averaging meets historical reality. They talk about a human Wikipedia editor writing an article about a very specific historical figure. So let's say the inventor of the first train coupling device.
Which is very specific.
Right. It is precise, it is factual, it lives on the very edge of the bell curve because it's a rare, highly specific piece of information. But when a user feeds that raw fact into an AI and asks it to, expand on it, the AI regresses to the mean.
It looks at its vast training data regarding 19th century inventors, and it determines that the most statistically common way to describe those people is with these grand, sweeping language choices.
Right, so it smooths over the specific fact.
It completely obliterates it, really. The AI suddenly describes this obscure railroad engineer as a, quote, revolutionary titan of industry whose visionary legacy reshaped the tapestry of modern transportation.
Which, I mean, that means absolutely nothing.
Nothing at all.
It's like taking a really sharp, high-contrast macro photograph of a mechanical gear and then running it through a filter that fades it into this blurry, soft-focus watercolor painting. The AI is shouting louder and louder that this person is uniquely important, but the actual specific details are entirely washed away in the process.
Exactly. It puffs up the significance of the subject matter to match the statistical average of how, important people are described online.
No, wait, let me challenge this for a second. Because human beings use flowery language too, right?
Yeah.
A human author writing a biography might absolutely call Andrew Carnegie or Cornelius Vanderbilt a titan of industry. So isn't the AI just mimicking good, descriptive, elevated writing?
Well, the difference is a human uses those phrases when they are earned, and more importantly, when they actually fit the context. A human understands the semantic weight of the word titan.
Oh, okay.
The AI does not understand meaning. It only understands probability. So it just applies those heavy, elevated words indiscriminately to literally everything.
I see. So it's sort of like a guy showing up to a casual Sunday brunch wearing a full bespoke tuxedo. Like, technically, yes, he is dressed up. He's wearing high-quality, good clothes. But he is entirely out of place for the actual context of the situation, which is eating pancakes on a patio.
That is a great way to look at it.
The outfit just doesn't match the environment, and everyone in the room instinctively knows something is deeply weird about it.
That captures the dynamic perfectly. The AI is always wearing the tuxedo, whether it's writing about the geopolitical history of a nation or, summarizing the plot of a morning cartoon. And the Wikipedia guide actually tracks these specific linguistic threads of that tuxedo. Like, there was a measurable, massive explosion of certain vocabulary words in academic and public writing starting in late 2022 and 2023.
Oh, yes, the dreaded AI vocabulary list. If you are reading an article or a cover letter or a Wikipedia page and you see the words delve, tapestry, vibrant, crucial, or showcase, your radar should immediately be going off. The word delve is probably the most famous offender here.
Oh, absolutely. Its usage in academic papers just skyrocketed to an absurd degree the literal moment ChatGPT became publicly available.
Let us delve into the rich tapestry of this vibrant landscape.
Right, and it sounds sophisticated to the AI statistical model, but to a human reader, it feels instantly hollow.
But it goes beyond just swapping in SAT words, right?
Yeah.
The Wikipedia editors highlight structural tells as well. The AI structures its sentences in ways that humans rarely do.
Yeah, the most prominent structural tell is the AI's avoidance of basic copulative verbs.
Okay, let's define that for the listener really quick.
Yeah.
What exactly is a copulative verb?
Sure, so a copulative verb connects the subject of a sentence to a subject complement. The most common ones are just is and are. So a human will write, the Louvre is a museum, it's clean, it's efficient, and direct.
Right.
But the AI looks at the word is and calculates that it is statistically too simple for a high-quality response. So it replaces the copulative with a heavier, more performative verb.
So instead of the Louvre is a museum, the AI writes, the Louvre serves as a museum, or the Louvre stands as a testament to art, or the Louvre boasts an impressive collection.
Exactly. And our sources reference a study showing this significant double-digit percentage drop in the use of is and are across newly published academic writing in the year following the release of these large language models.
Wow.
Yeah, the AI attempts to add elegant variation, but the aggregate result is just this exhausting, overly formal tone that takes twice as long to read.
Then we have a structure called negative parallelisms. And this is the AI trying to sound incredibly thoughtful and balanced, like it's hosting a moderated debate or something. It structures sentences by telling you what something isn't before telling you what it is.
Right, like, it is not merely a piece of software, it is a paradigm shift. Or, this decision is not just about cost, it is about fundamental values.
It constantly assumes the reader is on the verge of reaching an incomplete conclusion, so it swoops in with this profound-sounding parallel structure to correct you. It's incredibly patronizing, honestly, especially when you read 5 of those sentences in a row.
It gets old very fast.
But my personal favorite structural tell has to be the false range.
Oh, this one is fascinating once you start noticing it, because a true range requires a defined scale, right? Like from 10 to 20 pounds, or from Monday to Friday.
Right. But the AI will use the from X to Y structure to connect two concepts that don't belong on the same scale whatsoever, just to create the illusion of an expansive thought.
Yeah.
Like, it will write, From the singularity of the Big Bang to the complexities of human creativity.
Exactly. It's just a rhetorical trick. It creates a sensation of depth without actually conveying any rigorous logical connection between those two endpoints.
Okay, so those are the linguistic tells. The vocabulary, the avoidance of the word is, the false ranges. But the Wikipedia editors aren't just acting as literary critics here. They are hunting for literal, technical breadcrumbs that the AI leaves behind, like digital fingerprints that lazy users just don't clean up.
The formatting artifacts. Because when an AI generates text in its native chat interface, it uses specific coding languages to format that text. And when a user blindly copies and pastes that output into a different environment, like Wikipedia, those invisible formatting tags often get dragged right along with it.
Right, and the source guide highlights this really funny clash between Markdown and Wikitext. Let's clarify what those are. When you type in an AI chatbot and the bot wants to make a word bold or create a neat little gray box around a piece of computer code, it uses a lightweight markup language called Markdown.
Right. It uses asterisks or backticks to tell the browser how to display the text.
Exactly. But Wikipedia, however, runs on its own entirely different formatting ecosystem called Wikitext.
So a Wikipedia moderator will be reviewing a newly submitted article, and suddenly they will see a string of 3 backticks, followed by the word Wikitext, sitting right in the middle of a paragraph.
It's the ultimate smoking gun. The user literally copied the AI's internal Markdown code block instruction and pasted it directly into the public article.
Or you'll see a numbered list, but instead of using standard bullet points, the AI has generated little emojis in front of every single section header.
Oh, right, like a little glowing light bulb emoji for the idea section.
Right.
Or a little rocket ship emoji for the launch section. Humans writing serious encyclopedias do not format their articles with rocket ship emojis.
They absolutely do not. And another technical tell is the presence of placeholder text, because the AI is often aware of its own limitations. For instance, if you ask it to generate a properly formatted academic citation, it knows it doesn't have access to the current date to fill out the date accessed field.
Right, so it just generates the text access date equals 2025 XXX. And the human user is putting so little effort into the process that they don't even read the citation to fill in the X's before hitting publish. They just dump the raw output straight onto the internet.
But the breadcrumbs even go deeper than formatting. The AI creates this illusion of research that completely falls apart under scrutiny. It will fabricate digital object identifiers.
DOIs. For the non-academics listening, a DOI is a unique alphanumeric string assigned to a scientific paper or journal article. It's basically like a permanent social security number for a piece of research, and it provides a persistent link to its location on the internet.
And an AI will confidently generate a citation for a paper that sounds highly relevant, complete with a beautifully formatted, completely fabricated DOI. And when a moderator clicks the link, it leads nowhere.
This made it up.
Exactly. The AI didn't find a paper, it just probabilistically generated a sequence of letters and numbers that looked like a DOI. And similarly, it will cite real existing books, but fail to provide page numbers.
Because it hasn't actually read the book in the human sense. It just statistically knows that the specific book should contain information relevant to the topic. But my absolute favorite technical tell, one that proves how little attention people are paying, involves UTM trackers.
Ah, yes, the digital receipts.
Yes. A UTM tracker is a tiny snippet of code attached to the end of a web URL. Marketers use them all the time to track where traffic is coming from. So if you click a link in an email, the URL might end with source equals newsletter. Well, when ChatGPT searches the web and provides a link to a source, it attaches its own tracker.
Right.
And Wikipedia editors are constantly finding users who have copy-pasted these URLs into their reference lists, completely missing that the URL literally ends with source equals chatgpt.com.
They're leaving the price tag on the stolen tuxedo, essentially. Yeah. But if we pull back from the mechanics of Wikipedia moderation for a second, why does this granular level of detection actually matter to you, the listener? This isn't just about keeping encyclopedias clean. It's really about protecting your own cognitive load.
Because the sludge is everywhere now. It's in the emails you get from vendors. It's in the articles you read for industry research. It's absolutely flooding your social media feeds.
Right. And if you train your eye to spot these tells, if you can instantly recognize the false ranges, the avoidance of copulatives, the vibrant tapestries, you develop an incredibly efficient mental filter. You can look at a 3-paragraph LinkedIn post or a vendor pitch and realize within 2 seconds a human mind did not synthesize this information.
And it allows you to disregard that low-effort noise and save your attention for for actual human insight.
Exactly.
So we have established the baseline. We know what the default AI sledge looks like. We know it naturally regresses to the mean, it wraps itself in flowery vocabulary, and it leaves these messy digital footprints. So how do we force it to stop? If the AI wants to be a verbose, generic people pleaser, how do we engineer it to be a sharp, precise tool?
We build a cage for it. Which brings us to a truly brilliant piece of source material in our stack. It acts as the direct antidote to the AI's default idiolect. We are looking at the Dieter Rams system prompt.
Right, so for those who might not be deep into industrial design history, Dieter Rams is a legendary German designer. He was the chief design officer at Braun for decades, and his minimalist approach profoundly influenced the design language of companies like Apple. And his entire philosophy can be summarized in a three-word German phrase: Weniger, aber besser.
Less, but better. Rams believe that good design is unobtrusive. It strips away absolutely everything non-essential so that the pure function of the object can just speak for itself.
And what someone has done here, which is just a brilliant conceptual leap, is take that physical industrial design philosophy and translate it into a master system prompt to control a large language model.
Right, and a system prompt is basically the invisible set of instructions that governs how an AI behaves before you even ask it a question. It is the operating system for the conversation. And the Dieter Rams prompt is just an absolute masterclass in mathematical constraint. It completely overrates the AI's probabilistic desire to be generic.
Let's look at the rules of this prompt. Rule number 1 is utility first. The prompt literally commands the AI, prioritize function over form, answer the core problem immediately, eliminate any text, code, or explanation that does not directly help the user achieve their goal.
And that single instruction kills the vibrant tapestry dead in its tracks. It stops the AI from generating those 3 paragraphs of introductory throat clearing that usually precede the actual answer.
Rule 2 is restraint and neutrality. This one is fascinating because it directly tackles the AI's personality. The prompt says, you are a tool, not a companion. Remain completely unobtrusive. Never use conversational filler, emojis, enthusiastic affirmations, or introductory pleasantries.
It actively bans the AI from saying, certainly, I would be absolutely delighted to help you with that problem today.
Yes, like just give me the code snippet. I don't need you to be happy about it.
Exactly. And it also explicitly bans the AI from adding decorative summaries or moral conclusions at the end of its responses, because the AI has a deep statistical bias toward wrapping everything up in a neat, symmetrical bow. Like, in conclusion, while the challenges are many, the future remains bright.
Ugh, I see that everywhere.
The Rams prompt forbids that entirely. If the answer is 3 bullet points, the output ends after the 3rd bullet point. Full stop.
Then we get to the rules of absolute clarity and honesty and precision. The prompt uses this really beautiful phrase. It says, treat accuracy as a form of respect for the user's time. But the absolute kicker, the mechanism that gives this prompt its teeth, is the literal banned vocabulary list.
Right. The prompt architect clearly read the same data the Wikipedia editors did, because the system prompt explicitly lists words the AI is forbidden from generating.
It bans delve, tapestry, vibrant, crucial, showcase. And it goes beyond vocabulary into the structural tells we just discussed. It commands, do not use negative parallelisms to sound insightful. Do not use the rule of 3 to pad descriptions. Use basic verbs like is or are instead of serves as.
The prompt is actively engineering the idiolect. It is forcing the guy in the tuxedo to take off the jacket, roll up his sleeves, and just do the dishes.
It's an incredible analogy. Imagine having an intern who is technically brilliant, but they constantly want to use obscure SAT words to impress you in every single email. Eventually, you have to sit them down and say, please, just give me the raw data, stop saying moreover and does, and just tell me if the marketing campaign worked.
Right.
It's so interesting that we've built these supercomputers capable of processing human knowledge, and our first order of business is commanding them not to be annoying.
But that is the fundamental discipline of prompt engineering, right? You have to provide the boundaries. Because if you don't build the cage, the statistical water just spreads out everywhere. And if we look at the Google Gemini Best Practices Guide from our source stack, they outline a formal 4-part framework for building a system prompt this effective.
Right, so how do you build a Dieter Rams prompt from scratch? Google says you need 4 pillars: persona, task, context, and format. Let's map the Rams prompt to that framework.
Oh.
The persona is clear. You are an expert design consultant governed by Dieter Rams' minimalist philosophy. The task? Solve the user's technical or analytical problem immediately.
Yeah.
The context? Treat accuracy as respect, remain unobtrusive, remember you are a tool.
And the format, no conversational filler, no emojis, strict adherence to the banned vocabulary list.
It hits every single pillar perfectly, and Google pairs that structural framework with what they call the 3 C's of prompting. Be concise, be clear, and be consistent.
Let's talk about consistency for a second, because I think that's where a lot of casual users fail when trying to get good results out of AI.
Consistency refers to the strict maintenance of your own vocabulary when instructing the AI. The Google Guide points out a very common human error. So let's say you upload a spreadsheet to an AI and ask it to analyze the data. In your first prompt, you call it the spreadsheet. In your second prompt, you refer to it as the matrix. And in your third prompt, you ask it to filter the tab.
To a human, those are all just synonyms for the exact same thing. We use elegant variation naturally.
But to an AI, those are 3 entirely different semantic concepts. When you swap vocabulary, you force the AI to expend computational energy calculating whether matrix refers to the original spreadsheet, or if you are introducing a completely new mathematical variable, you introduce statistical doubt.
Oh.
So to control an AI, you must be as machine-like in your consistency as you want the machine to be in its output. If you call it a spreadsheet on line 1, it is a spreadsheet on line 50.
So we are building these rigid mathematical cages to keep the AI from regressing to the mean in text. We are demanded minimalism. But what happens when you apply those exact same rules to visual data? Because the philosophy of strict constraint applies perfectly to AI image and video generation too.
We see the exact same phenomenon. Visual AI also defaults to a generic sludge.
Right. I think most people have tried generating an AI image by now, and 9 times out of 10, it has that specific glossy, plastic, overly lit look. It just feels fake. But our sources include a guide on mastering the 5-layer prompt framework for visuals. And the authors make a really compelling argument here that plastic fake look is rarely a limitation of the underlying technology anymore. It is almost always a symptom of low-effort prompting.
It is the visual equivalent of asking the text model for the titan of industry. If you give a generic prompt, it gives you the statistical average of 1 million generic stock photos.
The source guide calls their solution the one-line fix. They contrast a lazy default prompt with an expert constrained prompt. So the lazy prompt is something like a woman holding a skincare product.
And think about the immense amount of statistical guessing the AI has to do there. What age is the woman? What ethnicity? What is the lighting like? What is the background? Because the AI doesn't know, it averages everything out into a flatly lit, perfectly symmetrical, soulless image.
But the expert prompt forces constraints using 5 distinct layers. Let's walk through them. Layer 1 is subject and action. The prompt doesn't just say a woman. It says, a 28-year-old Indian woman holding a translucent luxury serum bottle. You are locking down the age, the ethnicity, and the specific material properties of the object.
Then layer 2 is environment and lighting. And this is arguably the most critical layer for photorealism. The prompt specifies soft golden hour lighting coming from a window on the left. You are no longer letting the AI guess the light source. You're providing explicit vector data for where shadows and highlights should fall.
Layer 3 is where it gets highly mathematical, camera and lens. The prompt reads, shot with a Canon EOS R5, 85mm f1.4 lens.
What's fascinating here is how giving the AI specific mathematical constraints fundamentally alters how it generates pixels. An 85mm lens with an aperture of f1.4 has an incredibly shallow depth of field.
Let's explain depth of field for a second. It's the area of the image that is in sharp focus. If you have a deep depth of field, like a landscape photo shot on an iPhone, the mountains in the background are just as sharp as the person in the foreground. But a shallow depth of field means only a tiny sliver of the image, maybe just the subject's eyelashes, is in focus, and everything behind them melts into a soft, creamy blur.
Exactly. And the AI actually understands the physics of that specific Canon lens. It understands how light bends at an f1.4 aperture. So when you mandate that lens in the prompt, it mathematically forces the AI to blur the background, drawing the viewer's eye directly to the subject in a way that perfectly mimics high-end photography. You remove its ability to generate that flat stock photo depth.
You are forcing it out of the generic mean using literal optics. Then we move to layer 4, which is color and texture. Warm amber and cream color palette. Dewy skin texture showing subtle pores. You are demanding imperfection. And finally, layer 5 is style and quality tags. Editorial beauty photography, 8K ultra realistic.
You transition from vague descriptions to strict technical specifications. The AI is no longer guessing, it is executing a highly defined blueprint.
And we have a brilliant real-world example of this constraint in action in our source stack.
There's a specific system prompt designed for Google's Veal 3.1 AI Studio, which is their advanced video generation model. The goal of the prompt is to generate a 30-second cinematic video illustrating the concept of AI systems failing.
And if you read the prompt, it heavily utilizes the Dieter Rams philosophy of less but better. It strips away all the decorative noise.
It dictates the pacing down to the precise second. It says, Scene 1, 0 to 6 seconds. Extreme close-up of a developer's screen showing code. Scene 2, 6 to 12 seconds. Cut to a user reading the output. But the style constraints are where the RAM's influence really shines. The prompt demands minimal industrial design aesthetic, neutral colors, grayscale palette with a muted red accent for failure states, and a muted blue accent for stable systems. Absolutely no dramatic visual effects like sparks, glitches, or explosions, no human figures visible, straight-on orthographic perspective.
It actively bans the AI from leaning into those cheesy Hollywood tropes of computers failing. But there is a hidden layer of genius to this kind of minimalist prompting. There is an implicit, massive economic efficiency here.
Wait, how does minimalism save money?
It comes down to how AI processes information using tokens. In text models, a token is roughly a syllable or a word. In video models, tokens represent patches of pixels across frames of time. When you ask a video AI to generate a scene with sweeping camera movements, explosions, and crowds of people running around, the AI has to calculate the trajectory, the lighting, and the physics of millions of different elements changing in every single frame.
Oh, wow.
It requires an immense amount of compute power.
So it just burns through tokens.
Exactly. But by enforcing a minimal aesthetic, by demanding static cameras, slow zoom transitions, no human figures with complex joint movements, and no chaotic particle effects, you drastically reduce the amount of mathematical calculation the model needs to perform.
You are literally giving the machine less math to do.
You reduce the token processing requirement, which directly reduces the server cost and the generation latency. So the video renders faster, costs less, and ironically, it looks far more professional because it isn't drowning in chaotic sludge. Restraint isn't just an aesthetic choice here. It is a hard economic optimization.
Less, but better. Literally. Okay, so we know how to spot the AI sludge, whether it's a text tuxedo or the plastic image. And we know how to engineer highly refined, constrained AI content. So where are these two massive forces clashing right now? Where is the battlefield?
The battlefield is absolutely social media.
We are looking at a leaked strategy guide for dominating the 2026 LinkedIn algorithm. Internally, this algorithm update is apparently being called the 360 brew.
And 360 Brew represents a fundamental aggressive shift in how platforms distribute content. The platforms themselves are getting exhausted by the AI sludge. They realize that if feeds become nothing but vibrant tapestries generated by ChatGPT, users will just abandon the platform.
Right.
So they're actively penalizing the exact growth hacking tactics that worked brilliantly just 6 months ago.
The era of the automated generic growth hack is basically dead. So what are the new rules of 360 Brew? The most fascinating one to me is the pre-verification of authority. The algorithm now actively scans your entire profile, so your job history, your endorsements, your network, to verify your real-world authority before it even decides to push your specific post to the feed.
If you are a 22-year-old with zero management experience and you use AI to write a thought leadership post about navigating complex corporate mergers, the algorithm looks at the discrepancy between your profile and your content, flags it as low authority or AI-generated, and throttles the reach to zero.
The source guide also notes that if you have a confusing, keyword-stuffed, slogan-heavy headline, your reach is penalized. You have to demonstrate AI fluency in your actual work, but you absolutely must prove human empathy, hard-won experience, and vulnerability.
They are desperately trying to filter for humanity.
The second major shift is in content formatting. Document carousels, those swipeable PDF slides, they are still favored. But LinkedIn now severely punishes low completion rates. It used to be that just clicking on a carousel counted as engagement. Now, if someone stops swiping at slide 3, the algorithm views that as a massive negative signal. So the new strategy is cap your carousels at 8 to 10 slides maximum. Cut any introductory slide that doesn't add immediate high-density value.
And the guide explicitly says to ditch the polls.
Yes, ditch the polls entirely. In 2023 and 2024, polls were the ultimate engagement bait. Do you prefer working from home or the office? They generated massive reach because they were frictionless to click, but the algorithm finally realized they result in terrible follower growth and zero meaningful conversation.
Yeah.
The polls are being heavily deprioritized. And this is the most counterintuitive shift. The guide tells creators to completely eliminate hashtags.
That is a significant departure from a decade of social media best practices.
The source guide claims that hashtags haven't actually worked to boost reach in years. The 2026 algorithm doesn't need you to manually tag a post with hashtag leadership. It uses what is called an interest graph.
Let's explain the mechanics of an interest graph. Older algorithms relied on explicit signals, like hashtags, to categorize content. If you searched for marketing, it showed you posts with the marketing hashtag. An interest graph uses natural language processing to read the actual body text of your post. It understands the semantic context, extracts the core concepts, and dynamically plots your post as a node on a massive web of interconnected topics.
So if you write a detailed post about customer churn rates in SaaS companies, the interest graph knows it's about marketing and retention, even if you never use those words. Wasting precious character space on a block of hashtags at the bottom of your post is now a rookie mistake. It signals to the algorithm that you are using outdated tactics.
The overarching strategy the guide recommends for surviving 360 Brew is the 3 Cs: consistent, constant, critical. And the most vital of those is critical. You need a strong, highly specific human point of view. You have to take a definitive stance, even if it's controversial. Smooth, faceless corporate speak is dead because an LLM can generate that for free in 3 seconds.
And this is where we crash headfirst into a massive, almost hilarious irony in our source stack.
It is the central contradiction of the current internet.
While LinkedIn is re-engineering its entire multi-billion-dollar algorithm to beg for human empathy, vulnerability, and critical human thought, we have another source document in the stack that is literally titled Master Prompt DL Social Media.
It is an incredibly dense, highly engineered system prompt designed to mass-produce the exact kind of high-level, authoritative human social media thought leadership that the algorithm is desperately looking for.
The platforms are building radars to detect machines, and the creators are building stealth bombers to evade the radar. It's a pure arms race. Let's look at this master prompt because it really is a work of art. It is designed to act as an elite AI educator. But what makes it so powerful is the knowledge base embedded directly inside the prompt.
Right. The user isn't just asking the AI to write about a topic. They are preloading the AI's context window with hard, factual, highly structured data about deep learning. They are grounding the model so that the output isn't a statistical hallucination, it's based on an actual provided textbook.
And the content of that embedded knowledge base is actually a phenomenal crash course in how these AI systems actually function under the hood. It explains the mechanics of the very technology we've been discussing.
Let's dive into that knowledge base. The prompt begins by forcing the AI to understand the historical and technical transition from traditional machine learning to deep learning.
Right. Traditional machine learning was highly dependent on human intervention. The prompt outlines a concept called feature engineering. Let me try an analogy here. Imagine you want a traditional machine learning model to distinguish between a picture of a fresh apple and a rotten apple. In traditional ML, a human programmer has to manually define the features of rot. You have to write code that tells the machine, look for brown pixels, look for asymmetrical shriveled edges, look for lack of reflection. You are handcrafting the rules of observation.
And that works fine for simple categorization. But it fails catastrophically when dealing with highly complex, messy, real-world data like autonomous driving or natural language processing. A human programmer cannot possibly handcraft enough rules to account for every single shadow, weather condition, or pedestrian movement a car might encounter.
The rules just break down. So deep learning emerged. Deep learning models, which are built on artificial neural networks, don't require human feature engineering. They learn context directly from raw data, so raw pixels, audio waves, vast amounts of text. The master prompt uses a great phrase, deep learning lusts for data. The more raw data you feed it, the better it becomes at independently figuring out what a rotten apple looks like without you ever having to define the word brown.
But the knowledge base highlights a massive trade-off that occurs when you make that transition.
The black box.
Exactly. Traditional machine learning has high interpretability. If the model makes a mistake, you can look at the code and say, my rule for brown pixels was too broad. You know exactly why it made the decision. Deep learning offers vastly superior performance on complex tasks, but it has incredibly low interpretability. It's a black box. You feed the raw data in, you get an astonishingly accurate prediction out, but you do not entirely know the specific mathematical pathway the network took to arrive at that conclusion.
Which is terrifying when you think about it. The prompt goes on to describe the architecture of that black box. It's designed to loosely mimic the biological structure of the human brain. You have an input layer, which receives the raw data like the pixels of an image. You have an output layer, which delivers the final prediction like This is a rotten apple. And in between, you have the hidden layers, massive interconnected webs of artificial neurons performing complex math.
And inside those hidden layers are the core mechanisms of learning, weights and biases.
Let's construct how this math works conceptually. A weight represents the importance of a specific connection. Let's say the network is trying to predict the price of a house. It has inputs for square footage, the number of bedrooms, and the color of the front door. Through training, the network will assign a massive heavy weight to the square footage connection and a tiny, almost zero weight to the front door color connection. It learns what actually matters.
And a bias is simply an additional value added to the calculation to shift the activation point up or down, allowing the network to better fit the data even if all the inputs are zero.
So the network makes a forward pass. It looks at a house, runs the math of all those weights and biases, and guesses a price. It guesses $300,000. But the actual price was $400,000. It calculates its error and then performs a process called bat propagation. It sends an error signal backward to the entire network, tweaking millions of microscopic weights just slightly so that the next time it sees a similar house, it guesses a little closer to 400,000. It is constantly hunting for the local minima, the mathematical valley where the error rate is at its absolute lowest point.
But the element in the knowledge base that truly unlocks how AI can process the messy real world is the concept of activation functions.
The gates. The prompt says activation functions introduce nonlinearity. Why is that so crucial?
If a neural network only used linear mathematics, straight proportionate lines, it could only ever solve incredibly simple flat problems. But the real world is not a straight line. Data is messy, curvy, exponential, and unpredictable. Activation functions allow the network to bend and twist its mathematical understanding to fit those complex patterns.
I think of an activation function like a highly specific bouncer standing at the door of a nightclub, the nightclub being the next neuron in the sequence. The bouncer looks at the mathematical value trying to get in and applies a strict rule to decide if it gets through or how it gets modified.
That is a solid analogy. The knowledge base details several types of these mathematical bouncers.
There's the sigmoid function. This bouncer's rule is compression. No matter how massive the number is that walks up to the door, whether it's 10 or 10,000, the sigmoid bouncer forces it into a tiny space between 0 and 1. It turns everything into a probability. Like, you are an 80% likelihood of being a dog. Then there is the ReLU function, rectified linear unit. This bouncer is much simpler but incredibly fast. Its rule is, if you are a negative number, you become a 0. You don't get in. If you're a positive number, you walk straight through unchanged.
And ReLU is actually what allowed modern deep learning to train so quickly. By turning negative numbers to 0, it turns off large portions of the network at any given time, making the math much faster to compute.
The knowledge base also touches on how AI processes images using CNNs, convolutional neural networks. They act like pixel detectives. Instead of looking at the whole image at once, a CNN slides a small magnifying glass, a filter, across the image, mathematically hunting for specific patterns like edges, curves, or textures. They use a technique called max pooling to isolate the most prominent, important pixels and aggressively shrink the image down, throwing away all the irrelevant noise.
And finally, to prevent the AI from simply memorizing the training data instead of actually learning underlying patterns, the engineers use a technique called dropout.
Dropout is wild. During the training phase, they literally just shut off 20 to 50% of the neurons at random on every single pass. It's like training a professional athlete by randomly blindfolding one of their eyes or tying one arm behind their back during practice. You force the athlete or the network to become resilient, to build new neural pathways so it doesn't over-rely on one single dominant connection to make its guess.
It forces generalization, which prevents the model from breaking when it encounters new, unseen data out in the real world.
So that is the intense, highly technical deep learning math that the user has preloaded into this master prompt. But the real magic, the part that defeats the 2026 LinkedIn algorithm, is how the prompt instructs the AI to package that math.
Right. It commands the AI to read the user's specific platform request and adapt the output perfectly to that environment's distinct culture.
If the user asks for a LinkedIn post about deep learning, the prompt demands a professional deep dive. It instructs the AI to generate a bold hook that challenges a common misconception, use a relatable business analogy, extract a practical takeaway for executives, and end with a definitive call to action to drive comments. It is mathematically simulating the human empathy and critical thinking the algorithm demands.
If the user asks for an X or Twitter post, it completely shifts gears. It demands a viral thread format. Heavy use of emojis, punchy, fragmented sentences, and strictly one core concept per tweet to maximize readability.
And for Instagram, it formats the exact same knowledge into a visual carousel script, explicitly dictating what graphical elements should be on each slide to maximize completion rates. And, why are we spending so much time dissecting this? Because you, the listener, need to understand the mechanics of the algorithmic war you are consuming every single day. The platforms are deploying complex interest graphs to penalize sludge. Creators are deploying multi-layered, heavily grounded system prompts to perfectly mimic human vulnerability. Knowing the mechanics helps you cut through the noise, recognize the patterns, and figure out if the profound thought leadership post you are reading is a human being sharing their soul, or an AI just executing a professional deep dive parameter.
It's an endless game of cat and mouse, really, but ultimately it is relatively harmless when we are just talking about social media engagement and reach. It becomes a completely different, profoundly serious story when we apply this exact same probabilistic technology to actual business operations.
We are entering the danger zone here. It's one thing if an AI generates a slightly fake-sounding LinkedIn post. Nobody dies, nobody loses millions of dollars. It is entirely different when this same deep learning black box is plugged into the core infrastructure of a Fortune 500 company.
Our source for this section is a highly critical manifesto on enterprise AI failures. And the author opens with a quote that should terrify any executive currently rushing to integrate AI. The quote is, "The first time your large language model lies in production, it doesn't look like a bug, it looks like confidence."
A clean answer? A wrong answer? A user who trusts it anyway? It's chilling.
And it directly traces back to everything we just discussed regarding probabilistic math and regression to the mean. LLMs are probabilistic systems. They do not know facts in a database. They know statistical likelihoods based on token proximity. But over the last 2 years, massive businesses have been deploying them as if they were deterministic software.
Let's clearly define the difference between probabilistic and deterministic systems, because this is where the wheels are really falling off the enterprise AI hype train.
Deterministic software is the traditional code that runs the world. If A, then B. It does the exact same thing every single time with 100% reliability. A calculator is a deterministic system. You take 2 plus 2, you will get 4 a billion times in a row. It does not guess. An LLM is a probabilistic system.
It's more like a highly educated improv actor. You give it a prompt, and it probabilistically guesses the best possible continuation based on the context of the scene. You ask it the exact same question twice, you might get 2 entirely different answers depending on the slight temperature variations in its mathematical hidden layers. The manifesto argues that treating an improv actor, a probabilistic generator, like a deterministic calculator, guarantees catastrophic failure.
And the manifesto details the real-world consequences of that architectural failure. We are seeing mission-critical workflow disasters across industries right now.
Customer support bots are a prime example. Companies plug an LLM into their customer service portal to save money on human agents. But because the bot wants to be helpful, because its statistical mean is friendly resolution, it starts hallucinating. The source details bots confidently fabricating return policies that don't exist, or offering massive financial discounts to angry customers just to statistically resolve the text conversation. And because it speaks with absolute grammatical confidence, the customer believes it is a legally binding offer.
We are also seeing failures in software development. AI code assistants are designed to help engineers write code faster, but because they are probabilistic, they occasionally introduce silent, highly plausible-looking defects or security vulnerabilities into the code base. The code looks right, it passes the initial human visual review because it matches the statistical shape of good code, but structurally, it fails under load.
Or internal employee co-pilots. A company trains an AI on its internal servers so employees can search documents faster, but they fail to build deterministic boundary constraints. So a mid-level manager asks a co-pilot a vague question about team performance, and the AI helpfully summarizes the CEO's highly confidential spreadsheet regarding upcoming layoffs, exposing sensitive HR data to the entire company.
And beneath all of these operational failures is a massive, looming economic crisis for these companies. The cost. Because deep learning models process tokens, and remember, tokens cost compute power, the operational costs are scaling non-linearly.
The source points out that developers are now spending more time and more money debugging and fixing AI hallucinations than they would have spent just writing the code or answering the customer service tickets from scratch in the first place. The supposed efficiency mechanism has become a massive cost center. So what does this all mean? How do we fix a system that is fundamentally mathematically probabilistic?
By changing the entire paradigm of how we integrate the technology. The manifesto makes a defining statement for the next era of AI. The unit of design is no longer the prompt, it is the system. We have to stop treating AI as a magic conversational feature or a simple text box plugin. It must be treated as complex, multi-layered infrastructure.
We have to move from prompt engineering to system design. The manifesto outlines the mandatory architecture for any enterprise hoping to survive 2026. What does that architecture actually look like?
It requires surrounding the probabilistic LLM with strict deterministic guardrails. The first layer is RAG, retrieval augmented generation.
Let's explain RAG because it is the most important acronym in enterprise AI right now. Instead of letting the AI guess the answer to a question by relying on its vast, blurry, pre-trained statistical memory, you force it to retrieve the answer from a verified, version-controlled, proprietary database.
You ground the model.
Yes, exactly. When the customer asks about the return policy, the system first runs a deterministic search in the company's official policy document. It extracts that exact paragraph, feeds it to the LLM, and says, answer the customer's question using only the information in this paragraph. Do not use your outside knowledge. You are forcing the improv actor to read from a legally approved script.
The second architectural layer is tool calling. You do not ask an LLM to do math. It is terrible at math because it tries to predict the next number linguistically, not calculate it logically. So you give the LLM the ability to recognize when it needs to do math, and you give it a tool, a connection to a deterministic API, like a Python calculator.
But the probabilistic machine talks to the deterministic machine. If the user asks, what is my total bill minus a 15% discount? The LLM doesn't guess. It extracts the numbers, hands them to the calculator, waits for the absolute correct answer, and then formats that answer into a polite sentence.
Third, you implement safety filters. These are secondary, smaller AI models whose only job is to analyze the output of the main AI before it reaches the user, checking for policy violations, toxicity, or data leaks. It's an automated editor. Fourth, you must build evaluation suites. You cannot just launch an AI and hope it works.
Well,
You have to map the AI's outputs to actual business outcomes and score them continuously against an ideal baseline.
and finally, the architecture relies on tiered model routing. This directly addresses the exploding cost problem.
Right. You do not need to fire up a massive, incredibly expensive trillion-parameter model like GPT-4 or Gemini 1.5 Pro to answer a simple, how do I reset my password query?
It's like using a commercial jet engine to power a lawnmower. It works, but it's an absurd waste of energy.
Exactly. So a smart system uses a lightweight router model. It reads the incoming user query. If it's a simple deterministic task, it routes it to a cheap, fast, small model. It only escalates the query to the massive, expensive models when the context involves highly complex reasoning or multi-step analysis.
The manifesto provides a highly practical 48-hour correction loop for companies to fix their currently broken, hallucinating systems. Step 1, isolate the problem. Select one specific failing workflow. Step 2, build a 50-query evaluation set based on real, historical user questions. Step 3, define the exact expected correct output for all 50 queries. Step 4, run the current system against the benchmark. Step 5, measure the precise error rate, latency, and token cost. And Step 6, the mantra of the whole document. Fix the system, not the prompt. Add a ARG database, add a tool, add a router. Don't just type, please be more accurate into the system prompt and hope for the best.
If we connect this to the bigger picture, the paradigm of the tech industry has completely shifted. The author states, the competitive advantage is no longer access to the smartest underlying models. It is control over behavior. The models will eventually become commoditized. Everyone will have access to brilliant AI. The companies that dominate the next decade will not be the ones with the best raw intelligence. They will be the ones who possess the engineering discipline to build the most predictable, heavily constrained, reliable systems around that intelligence.
So if we can't fully trust the unconstrained AI to run autonomously in the enterprise, and if we have to build massive, expensive architectural cages just to make it do basic math without lying, what is the highest and best use of this technology for you, the individual listener, right now? How should you actually use it today?
You use it for synthesis and simulation.
Our final source document is from Google DeepMind, and it introduces a concept they call gems. A gem is essentially a custom AI expert that you create and control. You provide it with highly specific instructions, you give it a defined persona, and it permanently takes on that role for your specific use cases.
It is the Dieter-Rams system prompt methodology, but applied dynamically to any field of human expertise.
Exactly.
The DeepMind document outlines the core benefits of interacting with gems, getting specialized advice, challenging your own assumptions, and uncovering blind spots by stress testing your ideas through a simulated expert lens.
You are using the AI not to do the final work for you, but to act as a catalyst to make your own human work exponentially better.
I love thinking about this as building your own personal permanent board of directors filled with the smartest, most critical people in the world available to you at 2 a.m. on a Tuesday. Let's say you have a new business plan. You don't ask the AI to write the business plan. That just gets you a vibrant tapestry of generic sludge. You write the business plan yourself. Then you create a gem of a deeply skeptical, hyper-analytical chief financial officer. You feed it your plan and you command it, rip this to shreds, find the financial holes, tell me why this will fail in 6 months.
Or you create a gem embodying your most hostile, aggressive market competitor, and you ask it, how would you crush this product launch? What is my weakest feature? You are leveraging the AI's vast statistical knowledge base, its mathematical understanding of how CFOs or hostile competitors typically analyze data, and you're using it intentionally as a friction point. You are asking it to push back against your own inherent biases.
Why is this the most important takeaway for the listener? Because it completely reframes your relationship with the machine. Do not use AI to write generic Wikipedia articles. The moderators will catch your markdown tags. Do not use it to mass-produce LinkedIn posts. The 360 Brew algorithm will penalize your lack of real-world authority. Do not blindly plug it into your customer service portal and hope it doesn't confidently lie to your best clients.
Use the machine to stress test your own humanity. Use the probabilistic engine to refine, challenge, and elevate your own deterministic human ideas.
We started this deep dive looking at the default sludge. We saw how the statistical gravity of large language models pulls everything toward a blurry, verbose, generic mean. We explored how to clamp that tendency down with the absolute, unforgiving minimalism of the GTRAM's prompt, and how applying mathematical optical constraints to visual AI strips away the plastic fakeness. We navigated the irony of the 2026 algorithmic wars, where platforms demand human empathy while creators deploy deep learning master prompts to simulate it. And we tore down the enterprise systems that are failing catastrophically because they rely on the magic of prompts rather than the hard infrastructure of system design.
It represents a profound shift in how we must interact with technology moving forward. We are transitioning from being operators of tools to being orchestrators of highly complex, constrained systems.
But before we wrap up today, I want to leave you with one final thought, a provocative scenario to mull over as you browse the internet this week.
We know that the social media algorithms of 2026 are desperately hunting for authentic human empathy. They are actively scanning for strong, flawed, definitive, slightly messy human opinions to combat the endless wave of perfect, polished AI spam. But, well, if we can mathematically engineer an AI system prompt to perfectly simulate a DeterRAM's minimalist, and if we can use optics to perfectly simulate a master photographer shooting on an 85mm lens, how long until a creator engineers a system prompt to flawlessly simulate human flaws?
Oh, wow.
How long until we explicitly instruct the AI to simulate biases, to inject conversational hesitations, to mathematically model empathy and vulnerability specifically to beat the algorithm's detection systems? Are we rapidly moving toward an internet where the only way to prove to the machine that you are a human being is to instruct your own machine to be intentionally flawed and unhelpful?
To mandate mistakes. To artificially engineer a typo just to prove you have a pulse. That is really something to chew on.
The X-ray vision gets a little blurrier when the bones are simulated too.
It really does. Thank you for joining us on this deep dive.
Yeah.
Take these frameworks, the RAM's constraints, the 5-layer visuals, the understanding of probabilistic versus deterministic systems, take this critical eye, and go look at the internet differently. Don't let the probabilistic machine dress up in a tuxedo and convince you it's a titan of industry. Look past the vocabulary, see the mechanics, see the bones.
Until next time.
Keep diving deep.